So in this video, we're going to continue our discussion of solving for x. We're going to look at expressions that are a little more complicated than what we've seen before. So let's take a look at this first example. 4r minus 8 in parentheses minus 3r plus 12 is equal to 0. Okay, so the first thing that we need to do is we need to get these terms out of the parentheses. Okay, so for the first parentheses out here, since there is nothing sitting out here, or the reality is there's actually a 1 sitting out here, so you can imagine that there's a 1 out here, and then you simply multiply the 1 with the 4r and multiply the 1 with the negative 8, which is also called distributing it. Okay, and when you do that, you get 4r out minus 8, so you took care of that. And then out here in the second parentheses, again, imagine there's a 1 sitting in front of the negative sign. Again, negative 1 times 3r, and then negative 1 times positive 12. So that gives you negative 3r, negative 12 is equal to 0. At this point in time, combine like terms. So 4r minus 3r, those two is going to give you simply r, and then combine the negative 8 and negative 12, which gives you negative 20. And then you want to move the 20 over to the right hand side by adding 20 to both sides. So when you do that, you get r is equal to positive 20, and that's the final answer. Feel free to pause the video and work the problems, and then you can kind of always unpause and take a look and see if you're on the right track. Let's do another one. Now you have 7 times 2x plus 1 in parentheses is equal to 6 times 2x minus 9. Okay, so again, we're going to distribute the 7 with the 2x and the 7 with the positive 1 first. That's going to give me 14x plus 7. And then I'm going to distribute the 6 with the 2x and the 6 with the negative 9. So 6 times 2 is 12x, and 6 times negative 9 is negative 54. All right, so once I've done that, now my job is I'm going to basically combine the x's. So I can either take the 14x and move it to the right, or take the 12x and move it to the left. I'm going to prefer to take the 12x and move it to the left. The reason for that is because I'll get a positive x. So if I subtract 12x from both sides, I get 2x plus 7 is equal to negative 54. And then I'm going to move the 7 over to the right-hand side by subtracting 7 from both sides. That gives me 2x is equal to negative 61. And then I'm going to get rid of the 2 by dividing both sides by 2. So I get x is equal to negative 61 over 2. Now I can keep my answer as negative 61 over 2, or because this is an improper fraction, excuse me, I can change it to a mixed number, which ends up being negative 30 and 1/2. Okay, let's take a look at another problem. So let's say I have negative 6 over 5 times y is equal to negative 18. So now when I look at this problem, the first thing I need to understand is that this y, even though it's sitting slam bang in the middle of this fraction out here, the y is really, you have to treat this as a numerator, which means you can combine the y with the 6 by multiplying it. So I would recommend just multiplying the 6 with the y. So rewrite that as negative 6y over 5 is equal to negative 18. Okay. At this point in time, there's a bunch of different ways you can approach it, but I don't want to confuse you, so I'm just going to show it to you one step at a time. Excuse me. So what we want to do is first we want to get rid of the 5. Okay, so to get rid of the 5, since the negative 6y is divided by the 5, we're going to multiply both sides with 5. So when we do that, I'm left with negative 6y on the left, and the right hand side becomes negative 18 times 5 is 80. Okay. Now, this point in time, I can get rid of the negative 6, I divide both sides by negative 6. So I get y is equal to negative 80 over negative 6. So the negatives cancel out, which leaves me with 80 over 6. And then, excuse me, I'm sorry, I think I did this a little wrong. Negative 5, 5 times negative 18 actually gives me negative 90, not negative 80. So there we go, 90. Apologies for that. There we go. And then if I take 90 and I divide it by 6, I get 15. So y is equal to 15. All right. Let's do another problem. Now this problem is going to look a little different. 1/2 r minus 1/6 r plus 3 is equal to 2 plus 1/6 r plus 1. Okay, so now this problem, don't let the fractions confuse you, okay, or intimidate you. What you want to understand is that the first thing what we're going to do is we're just going to bring all the r's over to one side and then combine like terms and then take it from there, okay? So I'm going to take the positive 1/6 r, I'm going to bring it over to the left hand side, okay? So how do I do that? I subtract negative 1/6 r from both sides first. So when I do that, I'm left with 2 plus 1 on the right hand side, and then the left hand side becomes 1/2 r minus 1/6 r minus 1/6 r plus 3, okay? And so now notice carefully, the right hand side, okay, becomes 3. And I also have a 3 on the left hand side, but now I have to combine all these r's, okay? So to combine the r's, I can, either I can do them on the side, or I can go ahead and take the lowest common denominator of 2, 6, and 6, which gives me 6. And then I'm gonna, the first fraction, the 1/2 r, so 2 goes into 6 3 times. 3 times 1r is 3r minus, and then 6 goes into 6 1 time, so that makes it 1r on top. And the second one is also 1r, okay? Okay, so now 3r minus 1r is going to be 1r over 6 plus 3 is equal to 3, okay? So now what I'm going to do is I'm going to pull the 3 over to the right hand side. So subtract 3 from both sides. So I get 1r over 6 is equal to 0. At this point in time, don't let the 0 intimidate you, okay? So keep the 0 there. Multiply both sides with 6 to get rid of the 6 at the bottom out here. So 1r is equal to 0, okay? Because 6 and 6 cancel out, and 0 times 6 on the right hand side is equal to 0. And so essentially r is equal to 0. That's the final answer, okay? Okay, let's do another one. Let's say you're given 3x minus negative 2x plus 6 is equal to 4 times x minus 4 plus x, okay? So again, pause, try the problem yourself, okay? And then you can take a look and see how that problem is solved, okay? So let's take a look. So I'm going to distribute the negative sign again like we did before. Imagine there's a negative 1 sitting out there. We distribute that with the negative 2x and the positive 6. So that gives me 3x positive 2x negative 6, okay? And then I'm going to do the same thing with the 4 with the x and the 4 with the negative 4, okay? So that's 4x, I'm sorry, wrong color. 4x minus 4 4s are 16 plus x. Now I'm just going to combine the x's on the left and the x's on the right. So just to simplify things, so that's 5x minus 6 is equal to 5x minus 16, okay? And now I'm going to get rid of the x's by subtracting 5x from both sides. So when I do that, something very interesting happens. Essentially, your variable, which is x in this case, vanishes, okay? So anytime your variable vanishes, you really cannot solve for it. When the variable vanishes, you cannot solve for x or whatever the variable is there. Therefore, in this particular case, you're gonna report your answer as no solution, okay? All right, let's try one more problem. Okay, so let's say I have 0.10 times x plus 80 plus 0.20 x is equal to 8 plus 0.30 x, okay? So to solve this, again, I'm just going to distribute the 0.1 with the x and the 0.1 with the 80. So that's going to give me 0.10x plus 8 plus 0.20x is equal to 8 plus 0.30x. Okay, again, I'm going to combine the x's on the left hand side, so that's going to give me 0.30x plus 8 is equal to 8 plus 0.30x. And at this point in time, we can see that the left hand side is exactly the same as the right hand side. So let's go ahead and just, get rid of the 8 from both sides. Okay, first of all. So when I do that, I get 0.30x is equal to 0.30x. And then I'm going to divide both sides by 0.30. So I get x is equal to x. So you might be thinking, well, what does this mean? Well, this really means that if x is equal to x, then x can be any number, right? There's no condition anymore, right? Now, so by any number, and we're really thinking about real numbers out here, okay? So again, don't worry about imaginary numbers. That's a whole nother domain. But right now we're thinking about real numbers. So x can be any number, which is a real number. So what we can say is that the solution set is all real numbers, okay? This is also represented as a capital R, like this, with a double line out here, or it can be represented as a brace in another brace, ranging from negative infinity, comma, positive infinity, okay? And that's pretty much what we are going to cover in this video. Thank you for watching. We'll see you in the next video.